This video we're going to do question B here, where we're drawing complete diagrams of voltaic cells and calculating their voltage and all of that goodness. So here in our cell we've got carbon as an electrode, cadmium as an electrode, and then I've got nitric acid and cadmium ion. So I've listed those entities here and decided what the strongest oxidizing agents, strongest reducing agents are. So I've done that in here where I've listed them down, and you can see that my strongest oxidizing agent is up here, my strongest reducing agent is here, so that's going to be a half reaction, that's going to be a half reaction. So in here I've written those two half reactions and balanced them, and I know that the gain of electrons reduction oxidizing agent is my cathode, and then my losing electrons reducing agent is my anode. So I'm going to draw my cell here, and I basically have two half reactions. I'm going to draw them in beakers, but they don't have to be in beakers. And in my saltwater bridge, I'm going to put sodium ions, and nitrate would probably be fine, or if you wanted sulfate. We don't usually include chloride, so when we say salt water, we're not actually meaning table salt, because chloride has something called the chloride anomaly, which is going to get explained later, and it's kind of not something that we want to have in our reaction. So I'm going to have my carbon solid, and then I'm going to have my hydrogen ions and nitrate ions. Here I'm going to have my cadmium ions, and I'm going to have cadmium solid. This is going to end up being something like cadmium nitrate or cadmium sulfate, something like that. They don't ask that in this question, but it's got to be an ionic compound that kind of makes sense to be highly soluble and then unreactive ions. So here's my cell. I know that my carbon and nitric acid is my cathode. The cathode is positive. My anode is going to be the negative because this is a voltaic cell. My electrons are given off at the anode, so they're going from the anode to the cathode. I get my sodium ions going to the cathode because they're positive, they're cations, and my nitrates going to the anode because they're negative, they're anions. So I've labeled my diagram. I've got my external circuit, I've got my electrodes, I've got my electrolyte, I've got the direction of movement of my ions, I've labeled my anode and my cathode. Perhaps they would want me to write down the reaction, so I get 2 nitrates plus 4 acid particles plus 2 electrons become N2O4 plus 2H2O, and sometimes they ask for that. We're obviously running out of space, so I'm going to not do that because I've already done it over here. But what I do need to still calculate is the E cell, and so that's the cathode minus the anode. So it's the overall cell is going to be positive 1.30, that's the cathode's half reaction, minus the anode, and my anode in this case is cadmium, and so it's going to be minus negative 0.40 volts. And so this is going to be positive 1.70 volts would be to calculate the voltage of this reaction. Yeah, I think that that's everything it asks for here. Significantly, I picked this one because it's got an inert electrode. If they wanted cell notation I think is supposed to always list the anode first. So this is the cell notation. I think it should have anode listed before cathode, so I think it'd be cadmium solid, cadmium ion, saltwater bridge, nitric acid, and then my carbon solid. But the cell notation has got these lines that separate the, it goes electrode, electrolyte, saltwater bridge or porous boundary, electrolyte, electrode. So hopefully that helps you when you need to come up with these on